Hello. Okay, so today we're doing trig identities, another one. So we've got products to sums and differences. So we've heard of the sums and differences before, and now we're going to figure out what are their products. So that's our learning intention, to develop the understanding of the products to the sum and differences trig identities. We'll be successful if we can derive the products and if we can correctly use those products. Okay. So we have seen these products before. The sign of adding two angles, the sum of two angles, is sine A cos B plus cos A sine B. We'll call that equation 1. Subtracting, or the differences between sine of two angles, is equal to sine A cos B minus cos A sine B. We'll call that equation 2. If we had add the sum of two angles on cos, we get cos A cos B minus sine A sine B. Then we'll call that equation 3. And the difference of two angles in cos is cos A cos B plus sine A sine B, and we'll call that equation 4. Okay. So I'll go back to that one. All right, let us add equation 1 and equation 2 together. Okay, so we're adding those two together. So sine A plus B plus sine A minus B, well, that's equal to, if I'm going to add that together with this, that's going to give you 2 sine A cos B. If I'm going to add that together, well, that that cancels out. Okay, so if I divide by this 2, what I get is I get the product, sine A times cos B. The product of multiplying two angles together is a half of sine A plus B plus sine A minus B. The product of the two angles is half the sum, adding the sum and the differences of both angles. Okay. Right. So what happens if we're going to subtract 1 from 2? If I go sine A plus B minus sine A minus B. Alright, so what would that equal? So we're going to subtract them. So that will cancel this out. So sine A cos B minus sine A disappears. And cos A sine B minus becomes a positive. It's going to give us 2 cos A sine B. Okay. Now if I divide that by 2, I get the product of cos A sine B. Well, that's going to be a half of sine A plus B minus sine A minus B. Okay, so that's that proof. All right, so we've got the product of sine A cos B, the product of cos A sine B. Let us now add equation 3 and 4 together. Okay, so this is going to be cos A plus B adding to cos A minus B. So if I add these, that becomes 2 cos A cos B. If I add that, that just cancels out. Okay. So now if I divide by 2, I get the product of cos A and cos B. Well, that's going to be a half of cos A plus B plus cos A minus B. Okay. Now, what I'm going to do this time, I'm going to subtract 3 from 4. Yeah. Because the other way just cancels all of it out. And so this is the only possible way. So we're just going to start with 4. So we've got cos A minus B. I'm going to subtract equation 3. Okay. So if I subtract that from here, that disappears. And if I subtract this from this, so 2 negatives become positive, I get 2 sine A sine B. Divided by 2, you get the product of sine A sine B is a half of cos A minus B minus cos A plus B. Okay, and that's your 4 identities. You get, when you multiply the two opposite, yeah, we get half sine A plus B sine A minus B, and if we multiply the same, we get the causes. Okay. So those are the products to the sums and differences. Now, what happens, and if you're doing the exam extension, you will notice that they are on page 2 of your reference sheet. Okay, so you won't have to remember them identically, but you know how to derive them. They're on your reference sheet. Okay, now let's say we've got, let's let x equals a plus b and y equals a plus b. So that means that a is so if we're going to let x equals a plus b and y equals a minus b, okay, then x plus y is the same as a plus b plus a minus b, which will equal to a. And so a would technically be x plus y over 2. And if we want to do x minus y, we've got a plus b minus a plus b. Yeah, because 2 negatives become positive. So the a's cancel out and we get 2b. And so b is worth x minus y over 2. Okay. Alright. Using this rule, okay, what I'm going to do is I'm just going to write, basically, I'm going to write it in a different color. I'm going to write it in black. The sine of a plus b is x, plus the sine of a minus b, and we'll call that y. Well, that is going to be 2 lots of sine. A we said was x plus y over 2 times by cos of x minus y over 2. And what we have here is we actually have the sum and differences as a product now. Okay, and that's just a different way of kind of writing this, so that it now becomes the sum and difference of the products, rather than the products being the sum and difference, going the other way around. Okay, so the same thing here. So this is going to be so cos x plus cos y equals 2 lots of cos x plus y over 2, cos x minus y over 2. Yep. Same thing here. We've got sine x minus sine y. That's the same as 2 cos a is x plus y over 2. Sine is b is x minus y over 2. So this is cos of y minus cos of x, 2 sine x plus y over 2 sine x minus y over 2. Okay, so these are the products, and there's a sum. Okay, so we've got the products as sum or differences. Yep, and they're on your formula sheet if you're doing the exam, and the sum or differences as products. Okay, let's do some examples. If we want to express each product as a sum or difference, okay, we got sine of 4 theta cos 2 theta. So that is a product. So we're going to use let that be A, and let that be B. So we get this one. Okay, so that would equal a half cos A is 4 theta minus 2 theta minus cos 4 theta minus 2 theta. Okay, so if I just keep that half there for a second, I'll talk about that soon. So that's cos 4 theta minus 2 theta becomes 2 theta minus cos 4, that's going to, sorry, that's the sine and cos, and I was doing the wrong one, sine and cos. Here we go. So sine, cos, I'm actually supposed to be using this one. So we've got sine of 4 theta plus 2 theta plus sine 4 theta minus 2 theta. Well, that's sine 6 theta plus sine 2 theta. Okay. Now, because of that 2, if I either divide by 2 both sides or multiply by a half to both sides, it basically cancels those numbers out. So the solution is just sine 6 theta plus sine 2 theta. Okay. All right, let's do the next one. Cos 3a cos 5a. So I'm going to let this be my A and this part be my B. So we've got cos and cos, cos A, cos B. So I'm going to use this formula. That 2 will cancel out that half. So I've got cos of 3a plus 5a plus the difference plus cos 3a minus 5a. Okay, so that's just going to be 3 plus 5 is 8a. This is going to be negative 2a. Now, because it's even, it's just going to be cos 2a, because I'll just write it here as cos is an even function. Okay. Alright, so we get sine theta plus alpha multiplied by cos theta minus alpha. So we've got sine and we've got cos. This is going to be my A. This is going to be my B. So I've got sine and cos. Okay, so that's going to be a half of sine. A is theta plus alpha. And we're going to add that to our B. Theta minus alpha. Okay, and plus sine A minus B. Be careful because that becomes a positive. Okay, so half. Collect like terms. Theta plus theta is 2 theta. The alphas cancel each other out. That theta's cancelled out. Okay, and that's our final out. So a half of sine 2 theta plus sine 2 alpha. We will express the following as products. Okay, so we get 3x and x. Okay, so we've got minusing, so we get really 2 cos of x plus y, so 3x plus x divided by 2. Yeah, multiplied by sine 3x minus x over 2. Okay, using this identity here. So 3x plus x is 4x over 2. That's going to be 2x over 2. Simplify the fractions, we get cos of 2x and sine of x. Okay. Now we have cos x plus h minus cos x. So looking at, we've got subtraction of cos and cos. So we've got this subtraction. So to be, let's call this part our x, and this is our y. So I'm going to use this one, right? No, because remember we did equation 4 take away 3 to get a positive. If we did it the other way, we'd actually get a negative. So this is equal to negative 2 sine x plus h plus x over 2 sine x plus h minus x over 2. Yeah. Collecting like terms, that's going to be 2x plus h over 2. Those x's cancel, so it's h over 2. Alright, so we can finish this off as leaving it like that, or doing the fact that that's going to leave you x plus h on 2 and sine h over 2. Okay. So we've got this being our x, this being our y. We're adding two causes together, so it is going to be that identity. So I'll just write it down here, just transfer it. So we've got 2 cos of x plus y over 2 cos x minus y over 2, because we're adding two causes. So in this case, it's going to be theta plus x over 2 plus theta minus alpha over 2. Now that's all over 2. Yep. And plus, with cos, multiplied by cos, of theta plus alpha over 2 minus theta minus alpha over 2, and that's all over 2. Okay. Alright, let's clean something up. So that's going to add to 2 theta. So, yep, 2 theta over 2, because that would, yep, and we're going to then divide by 2. Clean the top, we're going to subtract, so that becomes 2 alpha over 2 divided by 2. So that's going to finally be, that's basically alpha divided by 2 is theta over 2 divided by, yep, and that cancels each other out, so it's going to be alpha over 2. And that's the final answer. Okay, thank you very much.